Imagine waking up one day in a world where the sensation of success is gone. Not the memory of it, but the biological feedback. You can still do things correctly, but your brain no longer acknowledges it. Instead, learning, true adaptation, only occurs when you get something wrong. This isn't just a philosophical puzzle. It's a question about the very wiring of your brain. Right now, deep inside your midbrain, a cluster of neurons is constantly making predictions about the future, about the consequences of your actions. When you reach for a cup, you predict you'll grasp it. But what happens when you miss? When reality is worse than your prediction, your brain doesn't just register surprise. It triggers a specific neurochemical event, a dip in the baseline level of dopamine. This is called a negative prediction error. It's not a punishment in the way we usually think of it. It's a cold, hard data point. The signal essentially says, the model of reality you just used is flawed. Update it. In our hypothetical world, this is the only learning signal that exists. The pleasant surge of dopamine that confirms a correct prediction, the one that reinforces a behavior and says, do that again, is absent. So, how would you learn to do anything? Knowledge would take on a different shape. Instead of building a tower of correct facts, brick by successful brick, you would be a sculptor. You'd start with a formless block of stone, representing every possible wrong action. Each mistake you make is a chip of the hammer, carving away a piece of what isn't true. You wouldn't be building towards a goal, you'd be revealing it by process of elimination. Your skill at chess wouldn't be knowing the good moves, but exhaustively knowing all the bad ones for a given situation. Mastery would be a quiet, empty space, defined only by the ghosts of a trillion failures. This method of learning isn't entirely alien. In fact, it's one of the most powerful forces we know of: natural selection. Evolution doesn't have a goal. It isn't trying to build a successful organism. It simply eliminates what doesn't work. A genetic mutation that results in a disadvantage is a mistake, and that organism is less likely to pass on its genes. What remains is, by definition, fit for the environment. Life on Earth is a 4-billion-year-old sculpture carved from a stone of non-viable forms. It learned to exist by failing in every conceivable way. But there's a problem with this strategy. Some mistakes are final. You only get to make the mistake of misjudging a cliff's edge once. How would you learn to perform surgery in a world where every slip is the only lesson? The first attempt would also be the last. Our entire civilization is built on mitigating the cost of error. We have flight simulators, architectural models, and apprenticeships. We have created systems to learn from success, both our own and, crucially, that of others. Because the price of learning from certain mistakes is simply too high. This reliance on observing success points to an even bigger fracture. Without the ability to learn from what works, culture itself would be impossible. You couldn't watch a master craftsperson and replicate their technique. Imitation is fundamentally about copying a success. Every single human would be an island of knowledge, forced to personally make every mistake required to learn how to knap a flintstone or plant a seed. The cumulative knowledge that underpins our species, the very idea of standing on the shoulders of giants, would dissolve. Each generation would start from zero. And yet, your brain does have a system that looks a lot like learning through elimination. It's called synaptic pruning. When you are a young child, your brain creates an explosive overabundance of neural connections, far more than you'll ever need. Then, as you experience the world, a process of competitive elimination begins. The connections that are used frequently are strengthened, while the vast tangled web of unused pathways is snipped away. Your brain becomes more efficient not just by adding knowledge, but by deleting noise. It carves itself into a more perfect thinking machine. This process of elimination is also the foundation of some of our most rigorous forms of logic. Think of a proof by contradiction. To prove a statement is true, you start by assuming it's false. Then, you follow the logical steps until you arrive at an impossible conclusion, a clear error. That error is the signal. It proves that your initial assumption was a mistake, and therefore, the original statement must be true. You arrive at certainty not by seeing the answer, but by proving that all other possibilities are incoherent. This is the core of how a computer algorithm like gradient descent works too. It doesn't know the right answer. It just knows how to measure its current error and take a small step in the direction that makes the error slightly smaller, repeating millions of times. What would this constant, low-level error signal feel like? It would be a world without confidence, without the feeling of mastery. Every action would be a probe into the darkness, and the only feedback would be the texture of the walls you bump into. There would be no sense of direction, only a growing map of places not to go. Psychologists have a term for what happens when an animal learns it has no control over negative stimuli: learned helplessness. Would we even try? Or would the motivation to act at all wither away in the complete absence of positive reinforcement? And that reveals the true nature of our own reality. Learning isn't a single mechanism, it's a duet. We have the cold, precise signal of error that tells us to update our model, to carve away the incorrect. It's the force that drives refinement and prevents us from getting stuck. But we also have the warm, reinforcing glow of success, the dopamine surge that says, yes, that, do it again. It's the force that drives exploration, motivation, and the courage to try in the first place. One without the other is incomplete. One is a map of where not to go, the other is a compass pointing toward a promising horizon. You need both to navigate the world.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.